Today we're going to be looking at a concept known as classes. Now, classes are quite difficult to explain in just a simple sentence, so let's just jump straight into an application where we might want to use them. So let's say in our code we want to represent some dogs, so we can say my dog and then underscore name equals Benji, something like that. Now we also might want to store the age of my dog, so my dog underscore age, and maybe we'll just say this is an integer of how many years, human years, or it doesn't really matter. We say dog years, doesn't matter. We also might want the breed, so my dog breed equals, and we want another string here, so let's call this a lab. We've got a Labrador called Benji, who's 5 years old. Now, what if we want to represent another dog? So we have to do all of these things again, name, age, and breed. So let's say your dog, name equals daily, like this. Let's say your dog age is 3 years, and your dog breed is a pug, like that. Okay, so you can see we've got quite a lot here just to represent this, just to represent these dogs. Quite a simple idea. What we really want to do is be able to group name, age, and breed. Because if we were to add another dog, we'd have to copy all of these out and paste them all back in. And first of all, that's taking a lot of space. But we then also need to be careful not to make any mistakes. So we might have their dog is called something like Bella. Bella is 6 years old and is a poodle. Now, this format is very susceptible to bugs. For example, down here, we've forgotten to type there, which means we're currently overriding this value. We don't want to do that. We want their dog breed equals poodle. So classes allow us to format this in a bit of a nicer way. So let's comment all of this out for now. And let's paste in this. So this is going to be how we would represent the same thing using a class. So what the hell does all of this mean? Let's start with line 21 here. So we've got my dog, and we're calling, it looks a bit like a function. It is technically a function. It's a bit of a different one, where we've got a dog and we want to call it Benji with an age of 5, and it is a Labrador. And the way that we would access this is by saying my dog and then a dot and then the attribute name. So if we run this, we can just see it in action. You can see Benji 5 lab, like that. Just before we move on to the explanation of how we're doing this with the class, let's just create another dog. So let's create your dog, which is a dog with the name Daily and the age of 3 and the breed of pug. And now you should see if we change all of these to your, we should get the right result for this as well. Daily 3 pug. Awesome. Okay, so let's start from the top. We've got class dog. So class is a keyword, a little bit like function in that we define a scope. We have to indent everything that we want inside of the class. Like for a function, we indent everything that we want to be inside of the function. And we indicate this with a colon. So we've got the class keyword and the name of our class. Now inside here we've got a function called underscore underscore init underscore underscore, or dunder init double underscore init. Init stands for initial, and this is the method that Python reserves. The reason we've got these underscores here is because most programmers wouldn't use this name, so Python can reserve it for Python's own use. And we define this function which runs whenever we call dog from the class name, like this. So what we're actually doing here is we are calling the init function. And when we call a function with 3 parameters, we would expect to see 3 parameters in the definition. Now, because this is a class function, also sometimes known as a method, we sometimes call functions methods if they are inside of a class, which helps us to differentiate between them. We would expect to see 3 parameters, sorry, the same number in the call and the definition. But here it works a bit different. We've got this self parameter here, which basically takes in this variable here, is the way I think about it. Down here, we're going to be using yourdog.name. Oh, sorry. Yeah, let's go over this one then. We've got yourdog.name, yourdog.age, yourdog.breed. So self is effectively a reference to this object. Object is an instance of a class. So we've got our parameters name, age, and breed, which are coming from the function calls, and we've got self, which represents my dog or your dog. And what we are doing here is we are binding these values that we pass in to the object. So here we are trying to access yourdog.name. Now this only works because up here we are effectively doing your dog.breed equals this value that we've passed in, and this allows us to collect all of these values into one. Now what this also means is that if we have another property that we want to add, another attribute, we can say self.owner name or whatever equals, and then we can add another parameter if we want to, and that means that we can make quick changes to all of the different objects. We would have to pass in another parameter for all of the objects, but it basically forces us to do that so that we don't accidentally miss anything out. So if we add in print my dog dot name, print my dog dot age, and print my dog dot breed, we still have quite a lot of repetition going on here. We've got this exact block repeated, and if we had more dogs, we would have to repeat these three statements again and again. And this isn't very nice. We would like to be able to write this once for all of them and be able to call it with just one statement, one kind of function call, just from my dog or your dog. Now, what I've kind of been hinting at there is we can actually do this as well with classes. Classes allow us to do more than just bind values to variables. So if we come under here, we can add another function, and let's call it getInfo. Or maybe printInfo might be better, doesn't really matter. Now, we need access to my dog or your dog, and so we're going to need self. And I should also mention at this point, we don't have to use self. We could technically use s, and then we would use s.name, but by convention, Python programmers always use self. It's really common to see self. Okay, so now that we've got the reference to the object, we can now print, and we want exactly what we've got here pretty much. So if we just copy paste that there, we also need to indent it across and change my dog to self. Like this. Okay, so now that we've got that, we can just get rid of these, and I'm actually just going to add another print statement to the bottom here so that we have an empty line at the end. Okay, so this is something a little bit annoying about Python that you don't really have to worry about in other languages. But if I highlight all of this, VS Code will tell me that here I've got kind of like a tab, and here I've just got a load of spaces. This only appears when I highlight, but basically if I hover over this def, it will tell us inconsistent use of tabs and spaces in indentation. So Python wants you to just use one like unified kind of spacing. Because we've got some tabs up here and spaces down here, it's breaking. Now VS Code, when you press the tab button, automatically gives you spaces instead, but because I copied this example over from my notes, it's kept the tab spaces. So if I insert a tab here, and I'm going to need to do the same here, here, and here. Now this clears up, and if we get rid of this method, we can see dot get info is now an option that shows up in VS Code. So let's continue. Let's press this, and it's a method, so we want the brackets. We're not passing anything in because we're just taking the myDog object, and we also want to do your dog.getInfo, and we just print an empty line at the bottom, or leave an empty space at the bottom. Looks a bit nicer, and if we run the code, we can see that we get all of the information that we want. So we can also add more methods. We can add as many methods as we want. So we could add def speak, self, and here we might just do print. Let's do self.name, and then plus colon, quote marks, and like that, and then maybe exclamation mark. So now if we get rid of these two calls and do dot speak, and why not, let's do it for both. Now if we run this, we'll see we get Benji says woof and Bailey says woof as well. So that's as much detail as I'm going to go into for now. The aim of this series was to give you a good introduction to programming and teach you basic Python syntax. So there are of course a lot of other things that you can learn, but they're a bit more specific. So for example, if you wanted to level up your knowledge of classes, I suggest you look into inheritance and polymorphism. So a quick rundown of these concepts. Inheritance is where a class inherits or takes all of the attributes and methods from another class. So for example, if we had an animal class that maybe defines a name and an age, we can then inherit from the animal class, and then we wouldn't need these. I'm just going to put those back because we haven't got an animal class at the moment. Then polymorphism is where we modify the methods that we inherit in. So for example, using the same example, if we had a dog class as well, a cat class, sorry, that also inherits from animal, we would be able to do my cat dot speak. And obviously we wouldn't want this to say woof. We would have to define these a bit differently. We'd have to override one of them or both of them if we had a default animal speak as just empty. And so this way we could have different subclasses accessing or being able to call the same method but doing something a bit different. So what that would mean is we could store my animals and say we want each of them to speak, but they do something a bit different. And that'll make a bit more sense if you look into inheritance and polymorphism. Again, not going to go into too much detail for now. As this is an introduction to programming as a whole, specifically based in Python, but not exclusive to Python, I'd also like to show you what an equivalent might look like in another language called Java. So here there is a lot more going on, and I'd like to be as descriptive as possible with this section, so please don't feel demotivated if you have no idea what's going on. Java forces you into using a lot of complicated stuff right from the start, so feel free to watch this rewatch this section or come back to it at a later date. One of the first things you might notice about this Java code is that we are using curly brackets or braces instead of colons to indicate our code blocks. And this is used by a lot of different languages like C++, Go, Rust, C#. Most in fact, different languages use brackets, curly brackets instead of colons. We also, in Java and most of these other languages, don't really care about indentation, but we do keep it in there just to make it a bit more readable, but just know that it doesn't actually break your programs. Something else that we should know about Java is that it is a primarily object-oriented language. That means it has object-oriented as a primary paradigm. So this means that whereas languages like Python and C++ support classes, they don't force you to use them. Down here we can see that Java has forced us to use a class with the same name as the file name in order to start the program. Now this doesn't really make sense from an object point of view, but it is what primarily object-oriented languages force you to do. So Java has a few different ways of creating methods depending on the context, and just below this class definition here we can see the first one, public static void main string args. Now that's a lot to take in all at once, but basically public static void main string args is where the Java program starts, and you can see the Visual Studio Code has given us a little shortcut here. It's not actually a line number, I haven't written this in, but it's just a shortcut to run the program. So let's go through each of these words one at a time. So public means that the method here is available from anywhere in the program. That means across different classes and across different files. This was to be private instead, then only other methods or references to the method would be allowed in the same scope. So if we would have another method here, private void test for now, we would only be able to access test from inside main or from another method here. We wouldn't be able to access it from this class up here. The next word is static. Now what this means is we don't need to create an object of the classes class in order to use the method. So if we go back to Python for a minute, if I was to do dog, which is the class name, .speak, and run this, you'd see that we get an error because it doesn't make sense to call speak on a template. It only makes sense to call it on an object. But if we were to have another function here called def, just test for now, and we don't pass in this self, we don't pass in the attributes for the objects, and we just say print test. If we were to do dog.test, then we're able to do this, as you can see here, because this is what's called a static method. It doesn't depend on the objects. If it does depend on the objects, like speak, get info, and init kind of, then it's called a dynamic method. So let's go back to this. Static means that we don't need to create a class's object in order to call main. The next spot here is the return type. So if we wanted to return an integer from the function, we would have to put int here. If we wanted to return a string, then we would put string. Now, because we don't want to return anything, there's a special keyword that is void. And void just means that we don't want to return anything. Now let's go to args for a minute. Args is just a variable name that we don't happen to use in the method. But this allows us to, when we start the program, well, when we run it rather, I can just do this and it runs it with no arguments passed into the program. But what we can do with, I think, most languages is we can run the program with some default arguments. And that would mean that these arguments, these values, come from outside of the program into this one. This also means that you can chain programs together. I've never actually done that, to be honest. I've looked at how to do it very briefly, but args is just where we would store that, and so we need to include it just in case we were to do that. And then here we've got the type of args, which is a string array, and an array is a collection of items like a list. So an array is kind of similar to a list. We've got an array of strings, and we're going to call it args, but we don't happen to use these in the program. And the reason why we need to include the type here, as well as down here, this is a type as well, but it's also the name of a class. The reason that we need to do this is because Java, like C++, if you remember from the for loops video, is statically typed, which means where in Python we can just do x equals 5, or that's a 6, x equals 5. In Java we would need to do int x equals 5. Static typing is also the reason that we need to have this void return value, or any type of return value, but in this case void, from the method. Because if we were to do something like int x equals method, we need to make sure that we can check that the return value of method is the same as the type that we want to use. Early on in the series, when we were talking about variables, I touched on how there are different types, different ways to separate different words in your variables. Now in Python, the standard is to use an underscore to separate different words, for your base variables at least. For classes, I should have said this earlier, the standard is to use a capital letter or Pascal case, which is a capital letter for every new word. I'll just take this out. Java has the same standard for class names. It has a different standard for standard variable names. And the standard here is camel casing, which is a capital on every new word, not including the first word. A lot of languages require that we use a new, or the new keyword. You see, we didn't have to do that just here in Python, but Java wants you to put a new keyword when you create a new object. You can also see here that VS Code has given me these hints: name, age, and breed. These aren't actually typed up. If I comment this line out, to comment in Java, we just add two forward slashes. we can see that this is exactly what I've typed, and if I take these out, these annotations are put in by VS Code in reference to this up here, which we'll get to later. So now let's look at the main dog class. We can see here at the top we've declared these variables, which means that we've said that we're going to use them. We've said what they are. We want a string that's called name. It's available publicly. Doesn't really need to be for now because we're not accessing mydog.name, but just to be a bit more consistent with Python, because they are publicly available by default in Python. We've got public string name, public int age, public string breed. So we haven't actually given these any values yet. We haven't assigned a value to them, but we have declared that they exist. And what this means here, because instead of creating it within a function, what this means is we have access to these a bit more directly within this scope here, within these two yellow brackets here. And if these were private, which you look at more in detail if you explore Java more, you'll see that this actually becomes quite an important concept because you can access these attributes from any of these functions, but not from outside, which is sometimes what you want. So fundamentally, this is working a bit different to Python. In Java, we've got scope-based attributes. Anything highlighted at the moment can access these variables, whereas in Python we use binding and pass a reference to the collection that stores all of the values. This method here is defined a little bit differently from the method before, and that's because we've got the same name here as the class name. And what that means is that this is a constructor. This will be called when the dog class, or when we create a new dog object. So this is kind of equivalent to double underscore init in Python. A constructor also can't be static because that wouldn't really make much sense. Dynamic methods impact a specific object, and when we're creating a new object that is specific to that object, we can't have a static constructor. Wouldn't really make much sense. Also, we don't need to include a return value because we're not returning anything except maybe the object itself, which is done automatically, depending on how you think about it. We can also see here that the dog method that we are defining here matches up a bit nicer to the new dog that we're using down here. The naming matches up directly to the method, rather than in Python where we match it to the class and then just go to the init method. Here we've got duplicate variable naming. We've got a name, age, and breed coming in as parameters, but we've also got name, age, and breed as part of the class. And so how do we differentiate between the two? If we quickly jump down to one of these two methods down here, you can see that name, the only name that this method has access to is the class attributes. So as soon as we see name here, we're just going to jump back to here and see what the value is here. But because we have a parameter defined as name within the constructor method, when we see name on its own, we're going to go to this one, because this one's kind of closer, if you will. We check if we've got it defined in the parameter, and in these two we don't. And then if we need to, we check the wider scope. So when we see name on its own within this method, that means that we're taking the parameter, and same with age and breed. Now, This method also needs access to the class attributes. And because we've got the same names going on, we need to use the this keyword in order to access the class attributes. Now, what some developers do, I tend to do this, is take out this and do name equals, and change the name of the parameter to new name. Ooh. Didn't mean to create a new VS Code like this. So now there's no duplication of any naming, and it's a bit easier to read. The drawback to this is that when you have these hints down here, you have new name instead of just age and breed, which looks a bit nicer. So it's a trade-off either way. It doesn't really matter which one you use, just try to be consistent. I'm just going to change this back to name, and name for consistency within this program. And finally, these last two methods, getInfo and speak, they aren't constructors, so we need the voids. We need to say that we don't want a return value, but we don't need static because, again, they impact the object themselves rather than just being a bit more generic. That was intense. There was a lot going on there. So again, I'd like to say, if that didn't make any sense, don't worry, come back to it at a different time. Maybe once you've learnt a bit of Java, it might be useful to come back to this, and then maybe some things will start clicking. But regardless, that's going to be all for this series. I hope you found it useful. I'd appreciate any feedback in the comments, and if there's something specific that you'd like me to do a video about, I'm open to suggestions. And I think that's just about it. One final note before I go. I've made all of the code available during this series available on my GitHub account, which is available at this link here. I'll also put it down in the description. I won't go too much into how Git works, but basically it allows you to put your code into a remote area that allows everyone to access it, or allows you to access it from different locations depending on your privacy settings. So here, this is set to public, so everyone has access to it. But yeah, that's been all. Thanks for watching, and if I make more videos, I hope to see you there.